Hey guys, this is Austin. Nah, ran out of idea for video intros. Anyway, a particle of charge q lies midway between two identical fixed charges, each having charge lowercase q and separated by a distance 2b. What is the net force on q when it is midway between the two fixed charges? Okay, let's just do A for now. Okay, so this is basically your diagram. You have three charges, q, q, and uppercase q, and then the distance is b and b. So for the first part, q is in the halfway. So basically the forces from both of these charges on the middle one are equal because they're the same charges and the distance is the same. And then the charges are just like the forces are in the opposite direction. So it doesn't really matter what your forces are. Your net force is going to be 0. And to the second one. Suppose q is displaced from the midpoint by an amount x as shown in the sketch above. If uppercase q and lowercase q have like signs, show that the net force on q is given by F net is equal to that thing. Okay, so to get the net force, you have two forces. One that this one exerts on this, and one that this one exerts on this. So for the first one, you have this. This is your k, 1 over 4 pi epsilon 0 times q times q over b plus x squared, because now your particle has moved x to the right side. Yeah, let's say right. And now, okay, so it said the particles are charge-wise have like signs. So the force that this one exerts on this one is going to be in this way. God damn it. And then the force that this one exerts on this one is going to be this way. So, and then let's just say that this way from left to right is positive. So your first F is going to be positive, and then the next one is going to be negative. And then, okay, so your next force is going to be k times q1, q2 over x squared, which in this case, your case is 1 over 4 pi epsilon 0, and then your charges are q and uppercase q, and then your distance is b minus x, and then that's squared. So now we just do some algebra stuff. We can factor out the lowercase q times uppercase q, and then 1 over 4 pi epsilon 0. So if you factor those out and then basically do some algebra stuff, you get this. Okay, so I tried to look up the name that we just did, but I couldn't find it. Anyways, so you basically multiply this part by this part, and then you get this b squared minus x squared. The whole thing is squared. And then, okay, so you basically combine these two fractions, and then this is b minus x squared minus b plus x squared. And then if you simplify that, you're going to get this minus b times qx over pi epsilon 0 times b squared minus x squared, the whole thing squared. Okay, so part C. Part C says show that if x is, I do not know how to say that. Then if the particle is released from its position shown in the sketch, it will oscillate with SHM with an angular frequency, I believe that is omega, given by omega is that thing, where m is the mass of the particle. Okay, so let's have a flashback to last chapter. We had simple harmonic SHM is simple harmonic motion. So we had a simple harmonic motion when your force was in this format. F was equal to a constant times x. So now we're just gonna have to calculate our F. Okay, so it's when it says x is, this basically means that in some cases, not in some cases, in all cases, x is basically insignificant compared to b because x is so small and b is so large. Yeah. So basically, your force is going to be this, but now you can ignore the x's for you can basically ignore the x squareds because that's going to be insignificant in your equation. So this part of your force is going to be pi times epsilon 0 times b to the fourth. And then, however, you can't just ignore x in the nominator because x is going to be significant here, because if you just decide to take that as 0, the whole thing is going to be 0. So you can just ignore x in your denominator, not your nominator. So this is going to be your new f. And yeah, so your f is in this format that we just said. A constant times x. This is going to be your constant, q over pi epsilon 0 b to the third times x. So, okay, another flashback. We knew that, okay, so a was equal to, okay, so we had minus kx is equal to ma. So if we solve for a in this equation, we got this, and we knew that k over m is equal to your angular velocity squared. So in this case, your k over m, so this is basically your k, and then your k over m is going to be this. q over pi epsilon 0 b to the third over times m. And then your omega is going to be the square root of that. Yay! Cool.